This video is on synthetic division. You're going to use synthetic division whenever you have a polynomial that is higher than a second degree. So an example of this would be if your polynomial was x to the third plus 5x squared minus 2x minus 24. So if you have a polynomial like this, you're not going to be able to use any of the different factoring methods that you may know to do it. The only ways to do it is with synthetic division or long division. Long division is going to take a lot more time and not work quite as well. I think synthetic division is a much easier way to do it. So that's what we're going to use to solve this one. So in a minute we're going to go over a couple different ways that you can find some factors to begin with. But for this first one, I'm just going to go ahead and tell you that 2 is a factor of this problem. So this is how you set up your synthetic division. What you're going to do is you're going to grab the numbers that are in front of x to the third, x squared, x, and then your x to the 0 or just your constant on the end. It has to be written in descending order, meaning the highest power has to be first, and then it goes down all the way to the end of it. So the first thing we're going to write is a 1, because there's an understood 1 right here. Then we'll write a 5, negative 2, you keep the sign of whatever it is, negative 24. Okay, so synthetic division, once you have this written out, you always pull down your first one. So we just pull down the 2, and then we say 2 times 1 is 2, and then 5 plus 2 is 7. So all we've done is we've pulled this down, we've multiplied here, and that gave us 2. 5 plus 2 is 7. Same thing, we're going to say 2 times 7 is 14. Negative 2 plus 14 is going to be a positive 12. 2 times 12 is 24. That gives you 0. Whenever you're doing synthetic division, this needs to be 0. If this right here is 0, it means that this is a factor of it. So what we have right now is we have x squared plus 7x plus 12. So what always happens with synthetic division is you're taking it from a third degree polynomial to a second degree polynomial. So if say this were a fifth degree polynomial or fourth degree polynomial, it would just go down 1. So with a fourth degree polynomial, this would be a third degree. So fifth degree, this would be a fourth degree. So it always just goes down 1. So now we have x squared plus 7x plus 12. So we can use some of our different methods to factor this. One way you can do is by grouping. You can say x squared plus 3x plus 4x plus 12. And you're going to get those numbers because you can add 3 and 4 to be 7, multiply 3 and 4 to be 12. So we'll just finish the factor by grouping. We'll pull an x out, x plus 3, and then we'll pull the 4 out, or plus 4, x plus 3. So we get x plus 4, x plus 3. So the other thing we got to do is we had this 2 up here to begin with, and it's always going to be x minus whatever you had there. So x minus 2. If this was a negative 2, it would be x minus a negative 2, so it would be x plus 2. So this is going to be your factored form. It's a third degree, so it's going to have 3 factors of it. That's going to hold true. It's always going to hold true that if it's a third degree, it has 3 factors. Sometimes the multiplicity is going to be different, and I'll have a video linked to multiplicity where I talk about that. But if I asked you just to solve this, then you would tell me that x equals 2, negative 4, and negative 3. But if I asked you to factor it, this would be the factored form. This next one's going to look a little different. We're going to have x cubed minus 3x plus 2. Now in this one we do not have we don't have an x squared in the problem. So the only thing that's going to change is whenever you're writing this over here, you start with your 1. You have to have a placeholder here. So like I said, it has to be in descending order, so starting with your highest one. If you don't have an x squared, you have to put a placeholder there, or it's going to throw off your problem. So we have this. I'm just going to go ahead and tell you that we're going to use a negative 2 to be a factor. So we're going to pull down our 1. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is a positive 4. We get a positive 1. 1 times negative 2 is negative 2, and we get a 0. So now what we have, it's x minus this, so x minus a negative 2, so x plus 2. We had a third degree, so now this is going to be a second degree, so we're going to have x squared minus 2x plus 1. So now if we wanted to finish factoring out, we would need to factor this right here. Let's go ahead and tell you this is going to factor to x minus 1, x minus 1. I know I mentioned multiplicity. This would be a multiplicity 2 because it's the same. Another way you could write this in factor form, you could say x plus 2, x minus 1 squared. Then if I ask you to list out the answers of it, the solutions of it, you'd say x minus 2 and 1. And you can also, I forgot to point this out, if you were to plug these back in right here, you would want to make sure you got 0, and that would check your answer. But this negative 2 already got 0 here, and that's equivalent. It works the same way with that. So now we're going to look at 1, and I'm going to show you how you find that first number that you plug in. So we got 3x squared plus 2x squared plus minus 19x plus 6. So we have it in descending order. I meant to write that as a cubed. So when you have it written like this, one thing you can do is a possible rational zero test. So all that is you're going to take your last number, which are your constant, which in our case is a 6. Then we're going to take whatever is in front of your highest power when it's in descending order, so it's going to be this 3 here. Then we're going to list out the factors of 6 over the factors of 3. So we got 1, or plus or minus, because it could be both. Plus or minus 1, plus or minus 3. Okay, so now what we want to do is we will have to pair these up. So I'm going to say 1 over 1 is 1, 2 over 1, we get from right here is 2, 3 over 1, 6 over 1. So we got 3 over 1, 6 over 1, and then I'm going to say 1 over 3, 2 over 3. So we got 1 over 3 plus or minus 2 over 3. Now one thing that's important is you get 3 over 3, same thing as 1, you don't have to write it twice. Same thing with 6 over 3 is 2, you don't have to write it twice. So what this is just giving us, these are our possible rational zeros. So one way you can do it is you could go in and you could plug every single one of these back into this until you found one that got you 0, but of course that's going to take forever. So one way that you can do that to kind of speed up this process is you can graph this right here in your calculator. Now if you didn't have a calculator, you would just have to plug these in and find which one gave you 0 and then start with that one. But I'm going to do a quick sketch of a graph for this one. So this is basically what the graph looks like. We're not too worried about this y-axis right here where the graph is at on it, because it doesn't really matter when we're talking about factoring it. We're just worried about where it crosses this x-axis. So it crosses 3 times, which makes sense because it's the third degree. Now not every third degree is going to cross 3 times. It just depends based on if they are imaginary numbers or not. But what I would do is I would pick, and of course this is going to be a lot easier with this graph, as you can see that it clearly crosses here at -3, crosses here at 2. We're not sure where it crosses here, but we're going to pick 2, and we're going to do our synthetic division with that. So we're going to say of course we're getting all these numbers from right here. So we'll do our synthetic division, we'll pull this down, we'll say 3, 2 times 3 is 6, 8, 2 times 8 is 16, -3, -6. We get a 0 here, so that works. Of course you can tell from this graph that works. That crosses it, and if you were to plug in a 2 right here, you would get 0, which means it is a root or a factor or a 0 of the problem. So now what we have is x minus 2 times give myself a little bit of room here, plus 8x minus 3. So if we're going to finish this out, we would need to factor what we have right here. So I'll give you a couple seconds to try and do that. Okay, so hopefully you got x minus 2, x plus 3, and then 3x minus 1. So those would be your factors of it. If asked for your zeros, you would say 2, negative 3, and 1/3. So this would be if I asked you to solve it. So remember what we did with this is we started with this. We didn't know what number to start with. So you can do your possible rational zero test. And of course you see that 2, 3, and 1/3 are all answers in it. But without graphing it, you would have no idea. So you can graph it, you can find which ones would probably work, do your synthetic division, get to this 0, and then once you get this 0, you can work it down. We went from 3rd degree to a 2nd degree, and then it was really easy. Now if you had like a 5th degree here, you would have to just keep working out. You have to go from the 5th degree to the 4th degree to the 3rd degree to the 2nd degree, and then you can work it out like this.